Hey y'all, it's Dr. Know-It-All. I'm going to do a little bit of a different video today. You can skip this one if you're not interested, but forgive me for being a little nostalgic. It's my birthday and it's a big birthday. I'm turning 60 today, or I just turned 60 today. And of course, that's got me thinking what's happened the last 60 turns of the planet around the sun. And it seems like a very long time, but also no time at all. But if you think back to, 1965 when I was born, the world was a very, very different place and there have been profound changes. And so I just wanted to talk a little bit about that and maybe talk about what the next 60 years might bring, although that is incredibly speculative. If you had asked people in 1965 what 2025 would be like, I doubt that they would have gotten it right. They probably would have said we'd be on Mars and we'd have flying cars and things like that, but I don't think anybody really imagined something like a digital smartphone or something. There was Dick Tracy, of course. They had the phone where you could talk, but that was very much of an analog device. It was like a radio, it was an analog radio with video stuff. So very, very cool thinking about, but it was definitely not anything like this Apple Watch. So the world is very different from how people imagined it. And I think the internet was something that people really could not have imagined. So let's dial it back to 1965, January 29th, when I was born. We were in the middle, the US and the Soviet Union were in the middle of a huge Cold War, which involved an arms race. We had the very first integrated circuits being built. They were very expensive and complex to build. And NASA, and I think 1965, was buying about 80% of them for use in their Gemini and then their eventual Apollo rockets, because they needed tiny little chips and they needed something that was able to stand up to the rigors of, being shook around all over the place on the way up to space. And of course, at the time, computers were the size of rooms, right? You have refrigerator-sized units with giant tape decks that were storing things, like literally spinning around, that kind of a thing. And I remember actually growing up, I read an Isaac. I was a huge science fiction fan. I'm going to get to libraries and reading and things like that in just a second. But I remember one Isaac Asimov, I think it was a short story, maybe it was an iRobot, I'm not positive. But anyway, he talked about the underground, like the entirety of Manhattan being a single computer. The idea was that the subway system and everything underground was basically replaced by one gigantic computer. That was the way people were thinking at that time. It was all extremely monolithic. You would build these massive, essentially what now are data clusters. So the weird thing is that we've kind of returned to that sort of modality now with data clusters. But in the meantime, we of course traversed an incredible shrinkage of computation from these room-sized things, first down to refrigerator-sized objects that you could store in other places besides these large data centers, then down into personal computers that you could have on your desk, right? That's an important thing. And of course, that still exists. That's what I'm talking to right now. Well, I'm talking to a camera, but I've got a Mac M1 Studio behind that. So anyway, there was a massive miniaturization of computers in 1965 that was not really projected to be the case. I think people were thinking that these were going to be giant and monolithic, and governments and maybe universities and large corporations, they could afford one or two of these things, maybe, or maybe they'd have to share them together to be able to have this compute power. No one really imagined the sort of Cambrian explosion that actually happened in terms of compute. The other thing, of course, that was not really projected at that time, well, there was two other things. Number one was the GUI, the graphical user interface, that was just sort of being developed. Actually, there were early, signs of this with radar, with light pens where you could touch on the radar screens, very analog-y. But MIT in the 1960s, and forgive me if I'm hazy on the dates, I'm taking a trip down memory lane. I didn't go and research this to remember the exact dates of everything. But in the mid-1960s, MIT was developing the first sort of user interfaces for computation that went beyond just typing in things. And if you're old enough like me to remember, when I went to college, they had dumb terminals. They were little CRT monitors with a keyboard hooked up to them, and you would type stuff in, and that would actually go off to a mainframe that was, potentially halfway across campus or something in a large building underground. If you ever wanted to print something on their laser printers, you would type it in and you would print it. You would walk over, you'd pick it up, you'd go like, oh crap, I misformatted or something like that. You'd go back to the terminal, you'd retype the stuff, fix it up, print it, walk back over again. It was quite the long period of time trying to get a paper properly formatted, especially back in the early 1980s. But anyway, the UI, that was something that was very, very important to the future of compute. And of course, Xerox PARC and then Steve Jobs taking that and commercializing it in the early 1980s with first the Lisa and then the Macintosh computer was a huge leap in the way that people interacted with computers at the time. But the other and just as important, if not more important aspect was networking these computers together. The original was ARPANET for the Advanced Research Projects Administration. I believe that's right. It got turned into DARPA later. They put defense in front of it. But at the time, we had small groups of geeky people in these academic institutions, these high-end academic institutions, again, MIT being a big one. They started working to network their computers together. And with the Defense Department's, blessing and their funding and stuff, to network these things together in a fault-tolerant manner. In other words, distributed computing, where one node could go out and you could reroute around that and get to another node. Of course, this was all very Cold War-y kind of stuff because they were worried about a centralized command structure, right? The Soviets launch nuclear missiles at the United States and they take out whatever that centralized command hub was. Then there's no way to tell the nuclear missiles to launch back at the Soviet Union and kill them all and wipe out the world, right? This, unfortunately, was the motivation for this thing. The idea was, what if we build a fault-tolerant system where there is no central node? All of the nodes are equally important. From that rose ARPANET, from that rose, of course, the internet, and from that arose the World Wide Web in the mid-1990s. So it took about 30 years to go from this initial idea to something where people had web browsers and they could graphically explore the internet. And it was a huge evolution. I would email my father in the 1980s from school. I would actually, get on one of those dumb terminals and I would type an email to his email address at Cleveland State University. He was a consummate academic professional. That was what he did his entire life. He was an academic, very purely. I'm not nearly as pure of an academic as he was. But anyway, so I would send him an email, right? And you would go from a dumb terminal to the main servers at Princeton. Those servers would then, the mainframes would then, you could actually see it. It would go to Rutgers, I think, first, and then I think UPenn, and then, I don't know, someplace in New York, right? So it would hop. You would actually see it, and it would say where it was hopping to, each of the different nodes that it was going to from university to university. And finally, it would get to Ohio, and I think it went to Ohio State, and then from there, it would go to Cleveland State. So you could see exactly how the network was connected together and how the messages were being transmitted. It was quite the insight. This is something people don't really know right now, right? You just bring up a web page and it's just magically there. You don't realize that there's all this hopping going on. There's all these protocols. There's all this communication going back and forth. So that was something that took 30 years to come to fruition. It was an amazing journey, and it was probably the most important thing that has happened to humanity in the past, 60 years for sure. And if not the 100 years or something. I think going to the moon and everything was amazing, but it was a rather Pyrrhic victory. I was 4 when people landed on the moon in 1969, and I was 7 the last time anyone has been on another planet. So I would consider that kind of a Pyrrhic victory. Although the amazing advances in computation that came out of it, that was not a Pyrrhic victory. That probably is the biggest thing that came out of it, was the miniaturization of computers, the kickstarting of the integrated circuit, world, the kickstarting of printed circuit boards, all of that kind of stuff was generated from that space race in the 1960s. So that was the big benefit that we got out of it. Unfortunately, going and landing on another planet, which, as a kid, I was just like, yeah, that's the future. We're going to be on Mars by the time I'm, in my 20s or 30s at the latest. And that just never materialized, unfortunately. I'm very happy to see SpaceX finally doing that again. There was a very, very long hiatus where I was like, man, I'm never going to see anything exciting in the space world again. And now between SpaceX and China, we're getting a lot of excitement and another kind of space race. So that I hope kids these days will be inspired by that and think about the world differently and think about the possibilities of traveling off planet and researching and discovering new things. It's very cool. We are explorers at heart. Another thing that was very important to me in growing up, I was in 6th grade when this happened. I did a demonstration project for 6th grade. It was like a science fair or something, and I built an electric motor. And I'm going to get back to libraries right now. This was pre-internet. For those young folks out there, you couldn't just Google it. You couldn't go on your computer. You couldn't go on your phone. There was no way to figure out how to do this. You had to go to the library. I was extremely fortunate. I lived about 1/3 of a mile away. It was a little over a half-mile round trip, but I could walk to the library, our main public library for Cleveland Heights, Ohio. I could go there and I could spend hours in that library. And I did. I would go and open up encyclopedias. I would get all the science fiction books. I pretty much went through, I think, all the science fiction books that they actually had in the library. But I could also get reference books. I could get how-to books, things like that. So I had a little bit of a walkable internet with me at the time, and I was extremely fortunate. Of course, unfortunately, my parents could not afford a computer, so I learned to program at first on a TI-35 calculator, and anybody who might remember that, it has the red LEDs and the batteries batteries only lasted a short time. And it had, I think, 35 steps of programming. I think that was why it was a 35, but it had no constant memory. So I literally had to take a piece of paper and I had to write down the code. And then I would take that, I would read it back in again, and I would type it all in and then run the code, do something. And then when I shut the computer, the computer off, when I shut the calculator off, that was it. It wiped the memory and I'd have to type it back in the next time. And of course, these were AA batteries. I think it ran on 4 of them, and you couldn't just leave it on because it had this LED, not LCD display. So it was very power hungry. So it was a giant pain in the ass. Fortunately, I think in 1981 or 80, I think it was 81 when my parents were able to purchase me a Hewlett-Packard 41C. The C stands for constant memory. That was another calculator. Again, I had a friend who had an Apple II and I was extremely jealous. I was like, oh my gosh, he can program on a real computer. But I had this calculator and I learned to, not only do RPN for mathematics, which I still do. I actually have an emulator on my phone that is the HP 41C emulator, and that's what I use when I need a calculator. So it's very nostalgic for me to do that. But I was able to learn how to program in a very, very restrictive environment with very, very poor debugging features. It was quite the interesting feat. I was also able to take a programming class in high school. We had one programming class. We had a couple of Apple IIs and this ancient mainframe that somebody had with 64 kilobytes of memory. And literally that was 64,000 tiny little iron donuts that had wire wrapped around it. And you would change the magnetic field, or you would run a current through it and you'd see what the magnetic field was to determine whether it was a 1 or 0. And I remember with some friends, we would pop that sucker open when it wouldn't work, and we would take voltage meters. We would sit there and go around between the different donuts and see which one had become disconnected or something. It was a lot of troubleshooting. It was a giant pain in the butt, but it was the thing that inspired me. I was like, this is the future. I can control a calculator. I can control this world inside this computer. It was very, very exciting, very intriguing. So that then led in 1982, 83 to me applying to a bunch of colleges, including Duke and Princeton and MIT and a bunch of other ones too. Not a bunch. At the time, every single application was a separate entity. So I think I did 5 or 6. I had my backup was Purdue University, if I remember, which is a great university, by the way. But anyway, I got in early action into Duke and I thought I was going there, and then I got into Princeton and I was like, well, geez, I better go there. I actually, a little pat on the shoulder for me. At the time, there were 2 separate admissions processes at Princeton. One was for everything else and one was for engineering, and I applied to the engineering program and got in, and that was supposedly substantially harder than getting in regular. So anyway, I did that and then immediately decided I didn't want to do EE. I really wanted to do computer science, but Princeton at the time didn't have a separate independent computer science program, so I changed over to physics instead. Now, of course, if I'd gotten into MIT, I would have gone there, but that was the one school I was rejected at. That is very sad because what I really wanted to do was artificial intelligence and computer science, and I would have been able to do that quite comfortably at MIT, not so much at Princeton. I changed to physics at Princeton, and it was a very humbling experience. Let me just put it that way. It was very, very difficult. There were incredibly intelligent people. I still keep expecting one of my classmates to win a Nobel Prize at some point in physics because that's how smart they were. I'm unfortunately not that smart. I may have the moniker of Dr. Know-It-All, but that's a tongue-in-cheek name, not for real. But anyway, I got through college, and my senior thesis is right back here, right there. That black document right there, it's called Times Dividing. It was on millisecond pulsars, and I did a whole bunch of computer modeling of these millisecond pulsars, which were relatively new discovery back in the mid-1980s, so it was actually pretty cool stuff that I was able to do. Nothing was ever published out of it, but I gave it to my advisor, and he either used it or didn't use it. I'm not exactly sure. But I went on to graduate school at Ohio State in physics, but my then soon-to-be wife, my ex-wife, I met her as soon as I got to Ohio State, and she was like, why are you doing this? You're so miserable. And I truly was miserable. I did 1/4 of physics at Ohio State and then jumped ship and did 2/4 of undergraduate English because I wanted to apply to the English PhD program, but they told me I had to, backfill some stuff in my English career. Now, what I'd done as an undergraduate was I'd done a physics major, of course, but I'd effectively done a music minor. Princeton did not do minors at the time, but I took about half as many classes in music theory and composition as I did in physics. So effectively, I call it a music minor because I did so much work in that. And I actually applied for music in several graduate programs, was not accepted to any of those. So it was a very tumultuous time in my life. I was very humbled at 22 years old and kind of casting about for what to do. And switching over to English really, really helped me. It was a major kind of breath of fresh air. I had actually, in high school, my mom, bless her, I was getting beat up all the time. Being a child, a geeky, super geeky child on the spectrum in the 1970s in Cleveland, Ohio was a terrible place to be. I was being beat up all the time. She managed to get me tested and put into a private school, university school. And so I went there from 7th grade through graduating high school, and it was wonderful. Some of my best friends like ever are from that time period. So, hey folks, hey Carl and Brian, etc. But anyway, when I graduated, I remember winning a sort of math award, which I kind of expected, but I also completely unexpectedly won an English award. And that stuck a little bug in my head that took, 4 years plus to mature. But at the point when I was like, wait, I could do English because I had this, little gold star where they said, hey, you're really good at this when I graduated from high school. So that stuck with me, and it actually ended up being very, very important. So I ended up switching, entirely, doing my master's and then my PhD in English literature. My dissertation's on Samuel Beckett, who is an absurdist playwright, very famous for Waiting for Godot, but many other plays and also novels as well. But here's the thing, what I ended up doing for part of my dissertation was I was using chaos theory, and I had to, of course, learn how to program this stuff from books. There was no Substack, there was no Reddit, there certainly wasn't any ChatGPT to help me, but I learned how to program this stuff, and I did simulations of language, and I also did sort of like attractor states. I modeled the progression of language through Beckett's plays. I actually remember typing in manually a bunch of the plays, the entire text of the plays, so that I could do this work to sort of model the language. Very, very primitive at this point, but it actually was published. So if you want to go look it up, you can go find that. My dissertation got published by Fairleigh Dickinson University Press in the late 1990s. But anyway, it's really primitive and kind of laughable at this point, but I was questing after this same thing. And that led me in the late 1990s out to California Lutheran University, where I was hired to teach English, but I immediately jumped ship again because it was the late 1990s. The dot-com bubble was happening. Everybody was really into multimedia. I was this young hotshot coming out of graduate school, and they were like, yeah, do you want to run this thing? And I was like, heck yeah. And that pushed me into 3D animation, pushed me into design, pushed me into film production, pushed me into theatrical production. I mean, a whole bunch of things. So a lot of stuff sort of spiraled. I was very, very lucky. My path through life has been very, very, noisy. Hasn't been a straight path at all, but I think it's been wonderful. And that eventually led to today. It led to me going back to school when my kids were relatively grown up at University of Georgia. I was able to take a class per semester starting in 2015, graduated in early 2019. And that master's in artificial intelligence has been crucial. I mean, that's been something that has been a pivotal thing in my life for the past 5 or 6 years, because of course I have a company based on that. I do work based on that. I talk to all of you based on that. It's very exciting to have that, but it's also really cool to blend that back with my 3D animation, my creative writing experience. All of that kind of stuff sort of blends together. So anyway, the world and I have taken very interesting paths. Again, if you'd asked somebody in 1965 what the world in 2025 would be like, they probably would have guessed what things looked like now, but bigger or more energetic or something like that. Not what actually happened. And certainly if you'd asked me at 10 years old what my life would be like, at the time, I think I wanted to be a scuba diver. I wanted to be an oceanographer. I wanted to go and look at things. Later on, I wanted to be an astronaut. I think both of those in my mind were exploration things. I wanted to be out in space or underwater exploring stuff. And now what I get to do instead is explore the mind, basically. I get to explore the mind of these silicon brains in artificial intelligence. It's extremely exciting to be able to have a chance to do something like that. So that brings us to 2025 with a world that would be almost unimaginable to people 60 years ago. What is the world going to be like in 2085? Well, first of all, I hope that maybe I might be around if I can manage to stay healthy. I've tried really, really hard. I'm actually just coming from the gym right now. I have, unfortunately, a cold that's going along for my birthday. And by the way, if you want to give me a birthday present, if you want to subscribe, that would be amazing. Thank you so much. But anyway, I'm trying to remain as healthy as I can so that I can hit aging escape velocity, essentially, and catch that ride. So it's the idea that if I can live one more year and the state of medicine in the world it, allows me to live 2 more years for that, that's great. And then I can live 1 more year and I get 2 more years for that. And exponentially, it gets further and further away from where I am right now. If I can do that, that would be amazing. If I could be alive at 120, that would be pretty darn cool. Will that happen? Don't know. I'm pretty convinced somebody who's like 40 years old right now will probably be able to manage to get there, but I think I might be a little too old, unfortunately. And that'll be sad because I would love to be able to be around for, a couple hundred years and see how things go. So I think we can safely bet on life extension. People will live longer by the 2080s than they do now on an average. Hopefully over 100 years, something along those lines. I think the second thing that we can probably project is that our work is going to be a very, very different thing in 2085 than it is in 2025. Same as it was different in 1965. You would dress up in a suit and you would go to the office and you would have your 3-martini lunch and you would come home as a male to your wife who would stay home all day and cook and clean. It wasn't the late 1960s. We hadn't had the hippie revolution yet. So it was wife at home doing the stuff, husband off at work, 2 kids, half a dog, all of that kind of stuff. Super average stuff. That's a very different world than we have today. Work is much more flexible than it used to be. I think it's going to become way more flexible and hopefully optional for us. Hopefully we won't have a revolution in the next 10 years of the disaffected masses revolting against the billionaire class. That very well could happen because what happens when you have robots and AI that's doing all the work and we as the proletariat don't have any money? We can't do anything. So unless that is handled very, very carefully, there could be riots and revolts, and in 2085, it could be the Stone Ages again. That would be a very distinct possibility about where we could go. I'm optimistic. I hope that won't happen. I'll cross my fingers that won't happen. But if we can manage to get through the next 10 years, I think, then we will have a kind of a golden age where people will be able to do what they want rather than what they have to live, because there will be an abundance, a superabundance of things. So we will be able to live comfortably and do what we want to do as opposed to what we have to do. And then finally, let's look forward to 2085. If we don't have some sort of massive civilizational collapse, I think we will be on Mars. I think that there will be a self-sustaining or close to self-sustaining colony by then. Again, that's a good reason for us to live another 60 years as a civilization, because then we have a civilization 2.0 that's out there. So I think that, if it weren't for Elon Musk and SpaceX, I think that we probably would not get there. But assuming that he lives a nice long life and SpaceX continues on the trajectory they're doing and other companies get with the program and decide to do it too. I mean, Blue Origin just launched a large ship. China is very competitive in the space. I think that we could see Mars becoming occupied at that time. So unfortunately, I think I'm stuck in this, like what we have today, but projected into the future and not imagining the new things that we'll have. Maybe we'll be cyborgy creatures. So by then we'll be half human and half silicon, and that's how we live so long, but we have perfect memory because we have some sort of SSD storage in our head. There could be things that are much more wild that are less dreamed of in our philosophy right now. But these are the things I can imagine at least. Definitely let me know in the comments what you all can imagine for the future. And, if you're my age or older or significantly younger, let me know, talk about your experience. What was your experience from the time you were born to today? What has changed? The world is radically different than it was 60 years ago. That is for sure. Alrighty, folks, thank you for going on this birthday nostalgia journey. 60, it's a big birthday. It makes me think a lot. So anyway, thank you for going along with this journey. The next video will return to a more normal type of video. And in the meantime, I will see you in that one. Bye-bye.